We had some people that were having a little trouble with B2 because it wasn't lined up perfectly along the compass points like the other problems were. And so it was a little bit more confusing for them to see. So we'll do this one together. Two forces are acting concurrently on a point. What third force is going to bring it into equilibrium? So force number one is pointing straight up here. It's pointing at 29 degrees. And it was pulling at 34.9 newtons. The second force was 47.1 newtons at 119 degrees. Well, 119 degrees would pull about here, and that force was 47.1. So 119 minus 29 tells me that this is a 90-degree angle, so that's cool. But right now they are tail to tail. We don't like that because my direction is going to get messed up. So I need to move one of them to the end of the other one. It doesn't matter which one we do, but I'm going to choose to move this one. So I'm going to bring it up and I'm going to point it here. Notice how it's still pointing in the same direction, and of course I'm still going to have 47.1 newtons is the side here. So now I've gotten rid of it down here and I'm just putting it up there. So now my resultant is going to start at my start and stop at my stop. And it's going to be there, and of course this is going to be my starting angle. So to find the resultant here, again, I'm going to have a magnitude and I'm going to have a direction. The way we find our magnitude is we're just going to use Pythagorean's theorem again. So 34.9 squared plus 47.1 squared equals, and we square root that answer, and we find that that is 58.6 newtons. So then if we're looking for this angle, again, the starting angle is always here. We're going to find this by using tangent to the -1. And we always do opposite over adjacent. So we're going to have the 47 on top and the 34 on the bottom. And that's going to tell us that this is a 53-degree angle. So if that's 53, that means that R is 53 degrees away from this other one. Well, we know this other one, look what it's pointing at. It's pointing at 29. So I'm either 53 bigger or 53 smaller. Well, 53 smaller, of course, would give me negative numbers. That's just ridiculous. So I must be 53 degrees bigger than 29. So if I take the 53 and I add 29, that, of course, means I'm pointing at 82 degrees. Now, I didn't ask what's the resultant. I asked what force is going to balance this out. So, of course, if I want to balance this out, I want to pull exactly opposite of what they were pulling. So if I'm going to pull this way, I'm just going to change my R into an E, the resultant, into an equilibrium. Well, if the resultant was pulling at 58.6, then if I want to balance it out, I have to pull just as hard as they're pulling. If I want to pull the opposite direction, though, that's going to be a difference of 180 degrees. So since this is a small angle, I'm going to add rather than subtract 180. So if I add that, I'm going to get 2, 8 and 8 makes 16, carry the 1, 262 degrees. That's all there is to it.